Okay, folks, I put two questions at the end that we've actually already covered ones like this, so be kind of a nice review. These are just questions that, if I was the AP exam, these are questions that I would be asking people to work through. So I think, what do I know? But if I had to make a wager on what kind of problems they'd ask, I'd be going with this. This is a classic problem. This is a problem of arriving and leaving. So you can see that it talks about, you have a gravel plant and you have gravel arriving at a certain rate. Okay, gravel arriving at this rate from time equals 0 to 8 at the processing plant. Beginning of the workday starts with 500 tons of unprocessed gravel, and then the plant processes the gravel at a constant rate of 100 tons per hour. So the idea is that the gravel arrives and it's unprocessed. Okay, so it's just like rocks. Then they take it away at a constant rate of 100 tons per hour, and it gets broken up and used however. Now, it says that G of T is equal to 90 plus 45. Oh, I already have it written there. There it is. G of T is that guy right there. Question A says find G prime of T. G prime of 5, excuse me. And so if I want to find G prime of 5, this is definitely a calculator problem. I go to my calculator and I type in 90 plus 45 cosine of T squared divided by 18. Now, it's important that you recognize this is shifted up 90 units and cosine 45, so up to 135 there. So my window, I'm going to make sure that my Y max is up to 140. I could go down -8, that's fine. But my X values just need to go from 0 to 8, so I'm going to go -2 to 10, and that should be enough. And now as I graph this, I should see this cosine graph. There it is. And we are wondering G prime of 5, the derivative of this. And so as if I calculate the derivative number 6, I type in 5, and it gives me -24.587. And it says, in correct units. And tons of gravel per hour squared. Okay, because the gravel, we're given a rate function the way it is. Okay, this is a rate function, arrives at a certain rate. And so when we find the derivative of a rate, we have it squared. It also asks what that actually means in context of the problem. And what it means is it's negative. So the rate at which gravel is arriving at the plant is decreasing at a rate of 24.587 tons per hour squared. Okay. We move on to question B. It says, find the total amount of unprocessed gravel that arrives at the plant during the hours of operation during this workday. So how much arrives? It's not wondering about leaving, it's just wondering about arrives. And so we just have to do an integral from 0 to 8 of G of T dt. And so if I look at my calculator, that's my G function. And so I'm going to calculate number 7, and I'm going to go from 0 to 8. And I get 825.551. That's how much arrives. Question C says, is the amount of unprocessed gravel at the plant increasing or decreasing at 5 hours? Well, what we want to do is we want to compare the rate at which it's entering, which is G of T, and the rate at which it's leaving. which is 100. It's leaving at a rate of 100. So if I can go ahead and check G of 5, so second calculate value and find G of 5, I get 98.14. 98.140 is less than 100. So it's arriving at a rate less than what it's leaving. So the amount of gravel is decreasing because G of 5 is less than 100. Finally, it says, what's the maximum amount of unprocessed gravel at the plant during the hours of operation of the workday? Okay, so the amount is equal to the start plus whatever arrives. So whatever arrives is from 0 to time equals x, we'll say of G of t dt, minus the amount that leaves. And the rate at which stuff leaves is 100 dt. Okay? So it starts at 500. 0 to x, and we'll go G of t minus 100 dt. We'll combine those two together. So that's the amount. So first of all, we need to check the ends. So we're going to check time equal to 0 and 8. So 0 is 500. We'll check at 8. So if I go into my calculator and I type in that G of t, which I have right there, and then at the bottom I subtract off 100, okay, and I calculate number 7, and I go 0 to 8, I get 25.55. Then I got to add 500 onto that. So 525.551. So it looks like the most is there right now. But I want to check where, when you're checking about these absolute maximums, remember, you have to check this endpoint. Whoops, sorry. You got to check this endpoint. You got to check this endpoint. You got to check where you have a local maximum. And the local max occurs when the derivative is equal to 0 and it changes from positive to negative. Well, if we think about the derivative of this amount, the derivative of this is 0, and then the derivative of this is just g, and the derivative of that is 0. So I want to check where g, which is my original function, okay, and get rid of that right there, okay, all right. Now I'm going to check out this graph. Or I'm sorry. So the derivative of this is G of t minus 100. So when you take the derivative, that goes away and that goes away. So I don't want to get rid of that 100. Sorry about that. And as I'm just going to move my window so my Y min is a little bit lower, so negative 50, so we can see it. As we look at this graph, we want to see where does it cross the x-axis. And it crosses right there. That's where it changes from positive to negative. So I'm going to second calculate that 0 value, enter, and enter, and it looks like it crosses at 4.92348. So just try once again, second calculate, number 7, and our lower limit is 0, and our upper limit, we're going to go 4.92348. And we can see how much it's gathering. 135, we have to add 500 on that, so we get 635.376. So it turns out that the maximum amount of gravel is 635.376 tons at time equal to 4.923 hours. There you go. Now, folks, there's no doubt that, getting this end part is challenging. But there's some pieces up here that are completely doable. So just realize that it's very abnormal to get all the problems correct. Okay? Got one more for you. It should be a little bit of review.